In 3.4, we're going to talk about finding slopes and using slopes like perpendicular and parallel slopes so we can write equations of lines. So first off, we need to go through what slope is again. So the slope is the ratio that represents how steep the line is increasing or decreasing. In the picture up to the right, you can see the setup of it and how we find the slopes. We find the difference in the y's, so that's the rise, and then we put that over the difference in the x's, so that's the run. So there's 4 different types of slope answers you could get. You could get a negative slope, a positive slope, a zero, or undefined slope. So if you look at your picture over here on the far right, a negative slope means that it's from left to right, it is decreasing, so it's going down. If it has a positive slope, then it's from left to right, it's increasing, so that would be going up from left to right. The horizontal slope or horizontal line creates a line that has a slope of 0. For a vertical line, that means that it's line N that has a slope of undefined. Alright, so this question is to practice finding the slopes of 4 different types of lines. The first one is line A. In our picture off to the right is the blue line. So we can see from left to right it's decreasing, so our slope should be a negative number. The 2 coordinates that are on the blue line of line A is 6, 4, and 8, 2. So those are the 2 coordinates we're going to use to find the slope of the line. So this is what your equation should look like. We need to subtract the y's on top. On the bottom it needs to be the x's, so 6 minus 8. So when we subtract on top, we end up with a 2 over negative 2. So slope is negative 1 for line A. So next we're going to do line B. So line B is the green one over on the far right. We can see that line B is increasing from left to right, so we are going to have a positive answer. So next we need to subtract the y's on top, so 4 minus 0, and then the bottom will be 6 minus 4 in the same order for the x's. So we will get 4 on top and 2 on the bottom, which simplifies down to a positive 2 for our slope for line B. So the next line we're going to do is line C, and it looks like it's kind of like a green line as well. And that one, if you notice, it's a horizontal line, so we need to write down our 2 coordinates for line C. On the top of our fraction, we subtract the y, so it'd be 4 minus 4. On the bottom, we need to subtract the x's, so it'll be 6 minus 0. The top will end up with a 0, the bottom will be a 6. When we divide that, we'll get a 0. So your final answer is going to come out at 0. When you divide 0 divided by 6, you get 0. Since it's a horizontal line, that makes perfectly sense. Alright, so for the next one, we're going to do the line D, which is the red line up above. And with that red line, we see it's a vertical line, so we expect that our slope should be undefined, but just to double check, we want to make sure we do the math to make sure. So in the setup, we know we need to subtract the y's on top, so 4 minus 0, the x's on the bottom, so 6 minus 6. On top we end up with a 4, on the bottom we end up with a 0. If you try dividing anything by 0, you end up with an error in your calculator, and that's because it is undefined. So our 4 answers are negative 1, positive 2, 0, and undefined for the 4 slopes. The slopes of parallel lines are when we have 2 non-vertical lines that are parallel if they have the same slope. This means that if we have 2 lines that have the same slope, then they are going to be parallel. So it depends what you start with. If we know that the 2 lines are parallel, then we know they have the same slope. Or if we start with the fact that we know that they have the same slope, then we know that the lines are parallel. So it goes both ways. The reason that it mentions 2 non-vertical lines is because we know that all vertical lines are going to be parallel. So in our picture, we can see that line M is parallel to M1 is parallel to line, or M2, which, is just saying that the slopes of the blue line and the red line are going to be identical. So next we have perpendicular lines, and again it's 2 non-vertical lines that are perpendicular if their product of their slopes is equal to negative 1. And this one also goes backwards, so if we have 2 lines that have a product of their slopes that's negative 1, then we know that they are going to be perpendicular. The reason we also said non-vertical lines in the definition is because all horizontal lines are going to be perpendicular to all vertical lines. So what I mean by the slope is negative 1, so when the product of their slope is negative 1, so if we have a slope of 1/2 and we have a slope of negative 2 over 1, and then we multiply them together, you'll get a negative 2 over 2, which then reduces down to a negative 1. So if you notice, something else you want to write into your notes is we can see that how the two slopes compare to each other, that they are reciprocals of each other, and they are the opposite sign, if you remember that back from Algebra 1. So perpendicular slopes have the same numbers, but they're reciprocals of each other, so they're flipped, and one is negative and one is going to be a positive number. And therefore, when we multiply them together, we'll end up with a negative 1. So that's why the slope, the product, will end up with being a negative 1. In this picture, there are 3 different lines. There's a blue, red, and a green line, and what I would like you to do first is I want you to find the slopes of all 3 of those lines. So go ahead, push pause, work it out, then push play to check our answers afterwards, and we can talk about which lines are going to be parallel. Alright, so line 1, or K1, has a slope of 4, and here is the work to match it. So you can see I subtracted 4 minus 0 on top, and then a negative 2 minus a negative 3 on the bottom, so I get a 4 over 1, which I could then reduce down to a 4. Your slope for K2, so the red line, should end up being a 4 as well, and here's the work to match it. For the green line, for K3, you should have gotten a slope of 5, and here is the work that matches that one. So you can see that the slopes of the top 2, so the first 2 lines, K1 and K2, match. This means that K1 and K2 are parallel lines. On this question, both of these, I would like you to try them out on your own completely. So you want to find the slope of the line from the graph. And then number 2, I give you 2 different lines, and I want you to tell me if they're parallel and how you know this. So please push pause, and then you can work them out, and push play when you're ready to check your answers. Alright, so for the first one, your slope should end up being a negative 1/3, and this is the work that you should end up getting. So you can see that the 2 coordinates, it decreases from left to right, so you want to make sure that you notice that you get a negative answer for your slope. And if you count it on your graph as well, that's kind of hard to do in this one since the graph goes by 2's. So you want to make sure you subtract your y's, subtract your x's, and then reduce your fraction down to negative 1/3. For number 2, the slope for line M, so that'd be this first one, is 2 over negative 5. If you hear some lovely music in the background, those are the band students practicing right now down the hallway. So for line P, that would be this one over here, and the red I'm going to use to show my work. Your slope for this one should end up being a negative 2/5 as well. So now that you see that your 2 slopes are identical to each other, yes, line M is parallel to P because their slopes are the same. In this question, we need to graph the points 3, 0, and 7, 6 so that we can graph the line H that passes through them. So go ahead and graph 3, 0, and 7, 6 and connect them together with a straight line. Then we need to find the slope that goes through those 2 points because eventually we need to find the line that's perpendicular to it. So we need to first find the slope between 3, 0, and 7, 6. So go ahead, push pause, and work out the slope between those 2 points. And when you're ready to check your answer, then you can push play. Alright, this is the work that I got for the slope. So you can see that I got 3, 2 is a positive 3 over 2, which makes sense. Because if I count up 3 and over 2, up 3 over 2, I get from point to point. And next I need to find the slope that's perpendicular to 3, 2. So if you remember, perpendicular, we need to make sure that if we multiply it together, that it will equal a negative 1. So that means that they need to be reciprocals. So it would have to be 2 over 3. And the sign needs to be different signs. So since my red line is positive, my perpendicular then will have to be the negative. So next, I need to graph the point 2, 5, so that's the point that we're going to make sure our perpendicular line is going through on our graph. So then we need to use this slope of negative 2, 3. And depending if you're going to the more to the right or to the left on your graph, there's 2 different directions we can go. So we can count down 2 spaces and to the right 3 and make a new dot, or you could count up 2 spaces in the left 3 and make a new dot. Those points would still be on the same line. This is what I have so far. So you can see that this blue line is now perpendicular to our red line, and it goes to the point 2, 5. So in the next question down below, the bottom of your screen, so it talks about a skydiver that makes a jump with 3 parachutes. So there's the green, the red, and the blue version. The graph shows the height of the skydiver from the time the parachute opened, so it'd be right here along this side, to to the time of the landing for each jump. So when they land, think of their height is at the ground, so that's why each over here is where they're going to land, and which statement is true. So what you need to do is go through all 4 statements, and then we need to find the one that is true. So the parachute was open for the same amount of time in jumps A and B. This would not be true because they would have to land at the same amount of time, so it would have to be from 0 all the way over to the minute. So the blue one is a little bit over 4 minutes, or over 3 minutes, sorry. The red and the green versions were both landing at 5 minutes, so that would not be true because that would only be true if the B and C were the same. So next is that B and C open at the same height. So if you look at it, the only spot where they're the same height is A and B, not B and C, because they're not starting at the same height, so that would not be true. For C, the skydiver descended at the same rate in jumps A and B. That means it would be the same steepness for A and B, and they're not the same. A is steeper than B. A and C have the same steepness, so A and C, they landed at the same rate. And that's really what this last one is that A and C descends at the same height, so D is your answer. So in this last slide, I would like you to go through and work out these questions yourself, and then you can come back and check all of your answers. So push pause, and when you're ready to check your answer, push play. Alright, so in line N, I'm going to do that in red right here. The slope that you get should be a 1/2. For the slope of line R, you end up with a -2. And the reason I put it as a -2/1 is so you can easily compare between the two of them. So this question is asking if they are perpendicular to each other, and that would be yes, because they are reciprocals of each other, and they have one that is positive, one that is negative, and also if you multiply them together, you end up with a -1. For the next question, which parachute is in the air for the longest amount of time? So the one that you should have put down was B and C are tied because they're in the air for the same amount of time and they land right around 5 minutes. For the last question, what do the x-intercepts represent in the situation? And the x-intercepts represent the time that it took for the parachutes to reach the ground.